Hi guys, welcome back to my channel. Today we're going to be doing a brief introduction on what a matrix is and what a matrix is used for. So a matrix is simply a way of storing information, like in a table. So we've got a really simple example here of a table which shows the final medal tally for the top 4 countries at the 2016 Rio de Janeiro Olympic Games. So we can see here the number of bronze, gold and silver medals that have been won by these top 4 countries. So let's go ahead and represent this information using our matrix. So just remember, a matrix is just like a simple table. So all we're going to do is we're just going to write in each of these values. So 46, 27, 26, and 19. Let's go ahead and finish this off. So here we go. This is our matrix. So I'm going to use a bolded capital M to represent my matrix here. Now there's a couple of key features of a matrix. The first one is the size of the matrix. So first off here we have the rows. So the rows are the ones going horizontally. So we can see in this matrix we have 4 rows. The next piece of information that we have is the number of columns. And I remember the columns because column has the letter L in it, and that forms the shape of a column going up vertically. So in this particular matrix, we can see that we have three columns. So when we write the size of our matrix, it's sometimes called the order of the matrix. We do that by multiplying the number of horizontal rows by the number of columns in that order. So in this case, this particular matrix, the size or the order of this matrix is a 4 by 3 matrix. Each individual element can therefore be referred to by whichever row or whichever column that it's in. So I'm going to take this example here. So for this particular matrix, I'm going to use a lowercase m to represent one of the elements in my matrix. And this is in the first column, the first row, first column. Okay, so let's pick a slightly different example now. I think I'm going to stick with green and let's have a look at this example here. So just like we did before, we're going to start with the row first. So this is in the 1, 2, 3. So this is in the third row and this would be in the second column. So this value here would be the element M32 because it's in the matrix M and it's in row 3 at column 2. Now this is just one kind of matrix. There are a couple of different types of special matrices, I guess you could call them. So if you have a square matrix, so I'll write this down. So if you have a square matrix, which is of the order m times n, so m is our number of rows, n is our number of columns, then if it's square, then these two values are going to be the same. So here's a simple example of a square matrix. This is of the order 2 by 2. And you can see here that the number of rows is equal to the number of columns. So there are some special instances where we use square matrices. And quite often you'll find we're not able to find certain values if the matrix is not square. We also have 2 other kinds of special matrices. So the first example we have is of the row matrix, which again of the order m times by n, where m is the number of rows and n is the number of columns, where we only have one row. So that's why it's called a row matrix. So this is an example of a 1 by 3 matrix since we have 1, 2, 3 elements. So if I was to write each of the names of these particular elements, this one is going to be M11, this one here would be M12, and this third element would be M13. Lastly, we have the column matrix, again of the order m times n, where m is the number of rows, n is the number of columns, and in this case, n, the number of columns, is equal to 1. So here you can see we've got a 3 by 1 matrix. So if I was to name each of these elements, this is going to be in the first row and the first column. This element here is going to be in the second row, first column, and then this last element is going to be in the third row, first column. So since this just has one column, it is referred to as a column matrix. So there you go, very brief introduction to different types of matrices, the size or the order of the matrix, as well as special types of matrices, the square matrices, rows and column matrices. All right, thanks guys, see you in the next one.